Okay, so the first thing we looked at was determining between our 1 and 2 variable data. And now we're going to move on and look at using scatter plots to identify relationships. So independent versus dependent. In 2 variable data, there is often a dependent variable and an independent variable. Okay, so the independent stands alone and the dependent relies on that independent variable. So if we consider the 2 variables, highest temperature for the day and the number of ice cream cones sold for the day, which variable is independent and which one is dependent? Okay, so nothing's going to influence the temperature. It is the temperature that it is. So with that said, that is our independent. Okay, number of ice cream cones sold, that's going to depend on how hot it is outside. So that's our dependent. Okay, if we look at some other variables, we want to identify the dependent versus the independent. So if we have height and age, depending on someone's age, that can say how tall they are. So our independent is our age, and our dependent is our height. Okay, so until you hit a certain age, you're going to get taller and taller. The next one, time spent studying for a test and the mark on the test. So in general, the more you study, the higher your mark will be. So our independent is the time spent studying, and the mark on the test will be the dependent. Okay, and number of bags of chips sold, and the cost of the bag of chips. Okay, so if we think about it, if the bags of chips are on sale, if they are cheaper, then more of them would be sold. So our independent is the cost of the chips, and the dependent is the number that are sold. Okay, plotting data. So when graphing data, the independent variable always goes on the horizontal axis. The horizontal axis is the x, and the dependent goes on the vertical axis, which is the y-axis. An ordered pair is a pair of numbers written as xy that represents a point on the coordinate plane. Okay, so when you're plotting a point, the x is always first, the y is second. Now, predicting a graph. So draw a sketch of what you think a scatter plot comparing the daily high temperature and the number of ice cream cones sold. So like we already talked about, the temperature is going to go along the bottom, and the number of ice cream is our dependent. It's going to go along the vertical axis, the y-axis. Okay, so if we're starting at a lower number, that means it's a cold temperature. And if we're going up to a higher number, then it's going to be a hot temperature. So in general, you're going to want to eat ice cream when it's hotter outside. So there's going to be a scatter plot with points. So as it gets hotter, the more ice cream cones that will be sold. Okay, so possible trends in graphs. A correlation is a relationship between two variables. There are three common trends to look for with a scatter plot. Okay, so when we read a graph, you always want to go from left to right. So going left to right with this first one, we notice that our points are going up. So this is a positive correlation. Okay, the next one, as we read left to right, we notice the points going down. This is a negative correlation. Okay. And we can also have it where it's not going up or down, there's no increasing or decreasing, and that means there is no correlation. Now, cause and effect. Even though there may be a relationship between two variables, this does not necessarily mean that one causes the other to happen. Okay, so examples of this. Since the 1950s, the concentration of carbon dioxide in the atmosphere has been increasing. Crime rates in many countries have also increased over this time period. Does more carbon dioxide in the atmosphere cause people to commit crimes? Okay, so this is what we're talking about, where these are both variables that are increasing, but they do not have anything in common. There's no connection here. Okay, so one isn't causing the other, it's just that they both happen to be increasing. Now, the second example, a scientific study showed a negative correlation between aerobic exercise and blood pressure. It claimed that the increase in aerobic activity was the cause of the decrease in blood pressure. Okay, so there is a connection here because it specifically is linking these two things together. It is telling us if you increase your aerobic exercise, then it will decrease your blood pressure. Okay. Now, reading scatter plots. So looking at this here, we notice that there is a negative trend from left to right. The points are kind of going down. So we have a negative correlation here. And this graph is talking about the number of missed classes and the exam scores. So when there are less days missed, the exam scores are higher, and the more missed classes that there are, the lower the exam scores. Okay, and this one here, we have unemployment rate, and we have the property crimes per 100,000. Okay, so what we see here is as the unemployment rate goes up, the property crimes also goes up. So this is a positive correlation. As unemployment goes up, the property crimes goes up. Okay. Now we can look at different types of graphs that we have. So looking at this one here, we're looking at a circle graph, or a pie chart we can also call it. In a survey of hockey fans, it is discovered that 33.2% support the Ottawa Senators, 28.6% support the Detroit Red Wings, 22.1% support the Toronto Maple Leafs, and 16.1% support other teams. Represent this data in a circle graph. Okay, so it's giving us percents. We're going to need to figure out how many degrees in a circle this represents. So the way we can do this is taking our percent, we're going to turn that into a decimal, and we need to multiply it by the number of degrees that are in the circle. So within a circle, there are 360 degrees. So this is 33.2 divided by 100 times 360. So this first one is going to be 119.5 degrees of the circle. For the wings, it's 28.6 divided by 100 times 360. And that's giving us 103 degrees of the circle. For Leafs, it's 22.1. We divide that by 100, times it by 360. And this is 79.5 degrees. And other, so 16.1 divided by 100 times 360. And that's 58 degrees. Okay, so if I start off with a line, I'm going to line up the protractor, and this is 119.5 degrees. So that is going to go to here. If I move this out of the way, I can create a line. Oops. Okay. Let's see if I can adjust this protractor here. Okay. Now I'll line it up here. Next one is 103 degrees. Create a line here. Oops. Okay, lining that up. Okay, 79.5 will bring me here. And that remaining amount is going to be the 58 degrees. Okay, so now that we have our lines, we can label all this. Oops. Okay, so our biggest portion is Sens. Next is Wings and Leafs. And last we have Other. Okay, now moving on, we have a bar graph. We can use a bar graph when the data are counted. A survey asked students what mode of transportation they normally use to get to school. The results were as follows: bike 6, walk is 9, bus is 15, car is 10. Represent this data in a bar graph. So with the bar graph, along the bottom, we're going to put all of our modes of transportation, and along the side we see that frequency is already labeled there. So with our bar graph, our bars can have spaces in between. So labeling this, we will have bike, and for bike there's 6, so that one bar is going to go up to 6. That can be filled in. Next it's walking, which is 9. Okay, bringing that up to here. We can color that in. Then we have bus, and that's going to go all the way up to the top. Colored in. And last we have car. Car is 10. And again, we can color it in. Okay, so that's our bar graph. Okay. Now, histograms. Histograms, we're creating certain ranges or intervals of data, and our bars are going to be touching, where with our bar graph we can have space in between. So the data here: a report of English marks must be prepared for the principal. One teacher has the following marks recorded. Prepare a frequency table and present the information in a histogram. Okay, so we have all of these numbers. And so a histogram should have between 5 and 20 intervals. To determine the length of each interval, first determine the range of the data. So when we talk about range, we need to look at our highest value and our lowest value. So when we look at this, we see our highest number being 95 and our lowest number being 41. So that is 95 minus 41, and that gives us a range of 54. Okay, when we create our intervals, let's say that we're going to go up by tens. So our intervals, we can start at 40 and go to 50. Okay, so that's including 40, but not including 50. The next one, include 50, go to 60, and then 60 to 70. $70 to $80, $80 to $90, and we know our highest number is 95, so we need to keep going here. It'll be 90 to 100. Okay, so we are going to do a tally of how many go in each interval and figure out our frequency from there. Okay, so 41 goes in that first one. There's no other ones under the 50. So moving on to the next one, we have 52, 57, 53. So there's 3 there. First one has 1, second one has 3. Third one between 60 and 70. So there's 69, 68, 63, 64, 66, 69, and 65. There's a total of 7. Between 70 and 80, there's a 75, 78, another 75, 79, 76, and 75. So there's 6. Between 80 and 90, so 80, 85, 84, 86, 82, 81, gives us 6, and one last number, 95, so there's 1 for that interval. Okay, so now that we have all of our data organized, we are going to create our histogram. So along the bottom is going to be the intervals, and this is representing the English marks. And along the side we have our frequency. Okay, so 0, 1, 2, 3, 5, 6, 7, 8. That's as high as we need to go. And along the bottom here, since we don't start until 40, we can actually create a broken graph along the bottom. So if we do a squiggly line like so, that represents that there is a beginning part of the graph. It's not included. Okay, so when we do this, we will go 40, 50, 60. Make sure you're moving the same amount every time. Keep it consistent. 80, 90, 100. Okay, so I'm kind of going every other line there. So our 40 to 50 interval, there's 1. So we're going to create a bar from the 40 to the 50, that's 1. 50 to 60 is 3. So we're joining that to the bar before it and going with a frequency of 3. 60 to 70 is 7. So the next bar joining goes up to 7. 70 to 80 we have 6. 80 to 90 we have 6. And 90 to 100 we have 1. Okay, so that's having the bars between the intervals. They are connected to have our histogram. Okay, so those are our different types of relationships, the correlations, whether they are positive, negative, or there is no correlation, and the different types of graphs that we have. So we have the circle graph, the bar graph, and a histogram that we have included there. So at the bottom of the page here, you'll see that there is another example for making a circle graph. So you can work on that as well as the textbook questions there. If you have any questions, please let me know.